Okay, we have confirmation. So, statistics and statistical methods. First, statistics is information science. We will teach how to produce new information, how to create new information, but there are specific things about this information. First, we speak about quantitative information. We will present this information in numerical way. This is the first. The second, statistics studies so-called populations. In Bulgarian, we usually translate population as население, but here we must translate population as populacja. This is the set of objects. Usually in psychology, this is the set of individuals, set of persons, and we study this set as a whole, not as particular individuals, but as a whole set of individuals. And the question is why we need to study population in psychology. You know that if you have a questionnaire, you can use it for individual diagnostics. Some person could fulfill this questionnaire, and you will have his or her scores, and this is enough. One particular person is enough. We use populations and we use statistical methods in psychology in two cases. The first one is when we create new question, new measurement tool, and before use it, we must test it. Each questionnaire must have some features, and we must test to be sure that this measurement tool is good. This is the first case. The second case is when we study relationships, when we want to know which variable is a result and which variables is or are factors. And then only one person is not enough. For example, if we want to study whether there is a relation between gender and motivation, and if we have only one person, of course, we will know his or her gender, and of course, we could measure his or her motivation, but this is not enough to say whether there are relation between gender and motivation. So we also need populations in this case. So after that, I will start with the next topic for simple and complex scales. And I will start with presentation. Okay. So let's start with simple scales. There are three basic simple scales. The first one is so-called nominal scale. Its mathematical description is if A, B, C, D, etc. are different categories of some variables, nominal scale means that A is different from B, B is different from C, C is different from D, and so on. For example, gender. We can see that male is different from female. So we have here two different categories, male and females, and female, and can say only that male is different from female. The next scale is ordinal scale. Here we have order. So if again A, B, C, D are different categories, we can say that A is less than from B, B is less than from C, and so on. For example, very typical example is education. Here you can see that without education is than primary education is less than secondary education, and secondary education is less than tertiary education. This ordinal scale has two special cases. These special cases are rank scale and score scale. And rank scale means that we order all individuals. First, we order all individuals and then prescribe a number. First, second, third, and so on and so on. So we use numbers to represent order. Score scale means that we order the categories of the variable and then also prescribe a number. First, second, third, and so on. So in both special cases, we use numbers, but these numbers show only the difference and order. So these numbers are not quantitative measures. So let's show the third scale. This is so-called interval scale. Here we can measure the difference. So we can say B minus A. How much is B minus A, how much is C minus B, and so on. For example, H. Here we can see that 25 minus 21 is 4H, difference of 4H, difference between 38 and 24 is 14H, etc. So here, these numbers measure the difference. But if you have ranks or scores do not measure the difference because the difference between ranks or the difference between scores is always 1. The difference between first and second is 1. The difference between second and third is also 1, and so on and so on. So these numbers So we cannot use these numbers for measure difference between cases, between individuals, and rank scale and score scale are special cases of ordinal scale. They are not special cases of interval scale because they don't allow to measure difference. These three scales are simple because we can use them directly. For example, if we want to measure, we can use this ordinal scale directly. And for example, if
because
you want to measure age, sorry?
the connection is quite patchy, and if you can repeat the last, please, because the connection is not good.
Oh, okay. I said that these three scales are simple because we can use them directly. For example, if we want to measure gender, we can use this nominal scale directly. And if we want to measure education, we also can use this ordinal scale direct, this interval scale directly. But there are phenomena which we cannot measure directly. Many phenomena in psychology are we can measure them only indirectly. For example, satisfaction, motivation, stress, burnout. And if we cannot use scale to measure directly, we must construct so-called complex or compound scales. And the most popular complex scale is so-called Likert scale. I think that you already know about this Likert scale, but what does that mean? I will use here my I must stop presentation to start whiteboard here. A Likert scale is a sum of so-called Likert items. And Likert items mean items, different statements, which are measured by the same score scale. Usually, we use score scale with odd numbers of scores. We can use 3 scores, 1, 2, 3, or 5, 1, 2, 3, 4, 5, or 7, or 11 scores. Why odd? Because when we use scales with odd number of scores, Then we have middle position. If we use 3 scores, 2 is in the middle. If we use 5 scores, 3 is in the middle. For example, if we use even number, 1, 2, 3, 4, then the middle is between 2 and 3. And then if one individual is in the middle, we push him or her in one direction. He or she must choose, and he or she will choose 2 or 3, but 2 is in the left from the middle, 3 is in the right of the middle, and we push him or her in one direction, in the left or in the right. So we prefer to use score scales with odd number of scores. Usually we use score scales with 3 or with 5 scores because we can give the names of these scores. So if we use 3 scores, 1 will be no, 3 will be yes, and 2 will be neither no, neither yes. If we use 5 score scale with 5 scores, then usually 1 is categorically no, 5 is categorically yes, 2 is rather no, 4 is rather yes, and 3 is neither nor. So we choose score scales with odd number of scores, and usually we work with score scales with 3 or 5 scores. After that, we have many statements about the same thing. For example, if we want to study motivation, we will have many statements about motivation, and each of them is measured by the same score scale. And after that, we sum the answers of each person. And in this way, we obtain so-called raw score of the Likert scale. But before use this raw score, we have to check our scale. We have to check our measurement tool. And there are 4 features that each scale must have. First is validity. And my question to you is, what does that mean? What does validity mean? Somebody? Suggestions?
The degree to which the data which has been obtained can be considered accurate and reliable, or the statistical method itself can be considered to be reliable.
The reliability is the next feature of the instrument of the tool. Validity is something different.
I know that there is internal and external validity.
Yes. And what does that mean?
I can say maybe. So internal validity, for what I can remember, is whether the scale measures all the aspects of the contract that is in question. This is internal. And
Okay.
external validity, when you compare the scale with other scales that measure similar things, whether it is whether it measure it is not the same as them.
Okay. Here
I explain it well, but
yeah. Here I mean external validity. So the classical definition of validity is whether the two measures that it pretend to measure. So if we want to measure motivation, we have to be sure that our two measures are exactly motivation. So the usual way to check validity is to compare our two with standard one. So if we create a Likert scale to measure motivation, we must compare our scale to already existing scale for motivation. But there is another way to check validity, and this way is to use qualitative methods. We can use observation, expert evaluation, focus group discussion, and so on. Sometimes qualitative methods are preferred because they are cheaper and faster, and we can faster check validity without spending time and money. This is the fastest way, and in some researchers prefer to use qualitative methods to check validity, but the classical way is to compare new scale with existing standard or standardized scale. So the second feature is reliability. And again, I will ask you, what does that mean, reliability?
Whether every time the results are not contradicting to each other, but similar, so we can so they could be considered reliable. I think there was something like that.
Okay, I will add under the same condition. So if we measure the same object with the same tool under the same conditions, we expect to have the same result. This means reliability, and the usual way to check reliability is with test and retest. This means that we test population of individuals, and after time, after 2, 3, 4 weeks, we test the same population with the same questionnaire. And if there is no difference between test and retest, then our conclusion is that our instrument, our tool, is reliable. If there are differences between test and retest, our conclusion is that our instrument is not reliable. But we must choose, we must decide the long the length of the time interval. Usually, this time interval is between 1 week and 1 month, but there are no strict rules. There are no equations. We cannot calculate this time interval between test and retest. But very short time interval is dangerous, because if the time interval is very short, then it is possible individuals to remember their answers and to copy them. And then during the retest, you don't measure if the person copy and paste their answers. This means that during the retest there is no measurement. There is only a repetition of their answers. On the other hand,
Haralampiev, if the period is short, but we slightly change the questions, is it considered a different tool?
Very interesting question, because in my practice in psychological research, we have changed questions between test and retest, because we use the test as the пак ми свъркна думата. Някой сеща ли се пробно изследване как беше?
Preliminary testing.
Preliminary, okay. We use test as preliminary testing, and we, if it is needed, of course, we make changes in the tool, and then when we use this new tool in the retest, formally the definition for the reliability is not correct, because this is the object is the same, but the tool is not the same. So formally the answer is that the each change, slight or not, doesn't matter. Each change makes this tool new tool. But very often in psychologically researches, we made such changes between test and retest. It's not exactly right, it's not correct, but it happens.
Okay, thank you.
Okay, so very short time is dangerous, but on the other hand, very long time period is also dangerous, because that there is risk of changing of conditions. We must measure the same object under the same condition, and when the time period is very long, it is possible to have different conditions, to have difference between starting point and ending point. So unfortunately, in these files that I sent yesterday, There are no appropriate data for validity check and reliability check, and we cannot make these checks now. So the third feature is consistency or internal consistency, but you already said internal validity. It's possible to find this as internal reliability. Here, the keyword is internal. After internal, you could find different words: consistency, validity, reliability, but this means that when we sum answers of many score scales, of many statements which are measured with the same score scales, we have to be sure that these statements measure the same thing. We have to be sure, for example, if we want to measure motivation, that all statements measure motivation. And usual way, most popular way to measure this internal consistency is so-called coefficient Cronbach's alpha. And we have enough data to measure internal consistency. So I will switch to PSPP to stop presentation again, to start PSPP, and to open data file called survey SAP. I sent it yesterday, two files, survey and staff survey. We will start with survey staff. And I forgot to send questionnaires. I will send during the break, but let's see in the questionnaire about this survey. Survey questionnaire here. We have different scales here. Scale A. Scale A, this is scale about optimism or pessimism. After that, we have scale B, scale C, and so on and so on. We will start with scale A. There are 6 statements, and we want to check whether these 6 statements are consistent or not. So, we have to choose analyze, and here we have reliability. I will choose reliability, and then I will move these 6 statements from the left in the right. But before that, if you click right button, you could choose here, prefer variables labels. This option is chosen now, but I can switch off, and then I will see the names. I will see here A1, A2, and so on. This is more convenient, and I will select these 6 statements from A1 to A6, move them to the right. Here you could see that the model is alpha. This is Cronbach's alpha. And I will check this option here, show descriptives for scale if item is deleted. After then, I will press OK. And before analyze of result, I will switch to the presentation again. Presentation here. And we will show you that the PSPP is very similar to the SPSS. In SPSS, we also choose analyze, but here is the option scale, and after that is the reliability analysis. In PSPP, the reliability analysis is in the main menu. There is no option scale. And here we also move this 6 statement from left to right. Also, the model is alpha, Cronbach's alpha. Here we can type the name of the scale, optimism. And here there is button statistics, and in button statistics there is option scale if item deleted. So the SPSS and PSPP are not the same, exactly the same, but they are very similar each other. So in PSPP, we used analyze reliability. Here we don't have field for the name of the scale. So here we cannot type the name of the scale, for example, optimism. This is the main difference. After that, let's go to the results. And first of all, here is the Cronbach's alpha. And the value is minus 0.24. For Cronbach alpha, there is intervals for the interpretation, and we can find them in, to say, Wikipedia, for example. Wikipedia. Type here internal consistency. Yeah, internal consistency. And these are the intervals about the interpretation of Cronbach's alpha. Here, you could see Cronbach alpha in these intervals, but values below 0.5 are unacceptable. In our case, this value is below 0.5, and this means that Cronbach's alpha shows unacceptable internal consistency. Why? What are the reasons for this unacceptable internal consistency? There are 3 possible explanations. First is presence of so-called reverse items. Reverse items mean that some of items are positive, are defined positively, but others are defined negatively. So in our case, here we have these 6 statements, and the first one, in or certain times, I usually expect the best. Obviously, this item, this statement, measures optimism. The second one, if something can go wrong, For me, it will. Obviously, this item measures the opposite, measures the pessimism, and so on and so on. And we can see here in this column, correlated item total correlation. I will try to enlarge, sorry, there is no option to enlarge numbers. Here we can see that 3 of the items are with minus and 3 of them are with plus. And if we read these items, we will see that this with minus, items with minus, measures optimism, and the items with plus measures pessimism. So, half items are correct, okay, but the half of them are reverse. And when there are reverse items, then alpha on Cronbach's alpha is usually below 0.5. But if we reverse the reversed items, we can enlarge Cronbach's alpha. How to reverse these items? We use transform. After that, recode into different variable. After that, also here, uncheck prefer variable labels. And after that, again, select, but select only reverse item. In our case, since our scale measures optimism, I will reverse these 3 items which measure pessimism. This was A2, A4, and A6. After that, I have to give new names. I usually use the same name, A2, but add R. R because we use record. And after that, press change. So the old variable is A2, the new variable is A4, A2R. For the A4, the same, A4R, change, and for A6, the same, A6R, change. And here, we can change the values. We must change old value with new value, but first we must know the initial scale. We must know here whether there are 3 or 5, 7 or 11 scores. So I will press cancel here and double click here in the row of A1 in the column of value labels. And here you could see that the scale consists of 5 scores. So I will start again, transform recode into different variables. And here I will press old and new values. And value 1 will be changed to value 5. Old value is 1, new value is 5, add. Old value is 2, new value is 4, 8. And so on and so on. 3, 3, 4, 2, and 5, 1. 8. So here you can see, you can see 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And then press continue, and then press OK. And then on the bottom of the file, we have these new variables. A2R, A4R, and A6R. And after that, I have to start from the beginning, analyze reliability, move A2, A4, and A6 from left to the right, and then move A2R, A4R, and A6R from left to the right. Press OK again, and let's see the result. Now, Cronbach's alpha is 0.8. So you can see that when we reverse the reversed items, we can enlarge the value of the Cronbach's alpha. So now 0.8 is between questionable and is between acceptable and good, because 0.8 is the border in these two intervals, but here we have equal than less than or equal to, so we can say that now our internal consistency is good. So this was the first possible explanation. When we have reverse items, then the value of Cronbach's alpha is low, is below 0.5. But there is another possible explanation, and this is when one or two items are not consistent with the others. Most of the items are consistent, but one or two are not. And we can check this using the last column here of this table, Cronbach's alpha if item deleted. And if item deleted, we expect internal consistency to decrease. If we delete some item and in the same time internal consistency increases, that means that without this item the scale is better. So we can compare these numbers here with the general alpha, general Cronbach's alpha, and if here we have numbers which are greater than general Cronbach alpha, that means that this particular item is not consistent with the others. So here you could see that all numbers are less than general Cronbach's alpha, that means that all items in this scale are consistent. And the third possible explanation of unacceptable Cronbach's alpha is when all items are not consistent. This is the worst situation because that means that our scale, our questionnaire, is not good, and we must start from the very beginning. But if there are only one or two items which are not consistent with others, this is not so big problem because we can create a scale without these one or two items. And you already see that when there are reverse items, this is not a big problem also, because we can reverse the reversed items, and Cronbach's alpha enlarges. So this was the third features of the scale: validity, reliability, and internal consistency. I will switch again to the presentation, and here are the screenshots from the SPSS. Here is this intervals for the interpretation of the Cronbach's alpha, the problems. We already saw these problems. Reverse item, how to code. The procedure is the same in the SPSS, very similar to the PSP. Values, and then new value of, and Cronbach's alpha if I'm deleted. So after that, we have to compute the raw scores of each person in our data file. For this, we use, we also choose transform. After that, compute. After that, we type here the new name, optimism, and then sum up the items. I will again uncheck preferred variable label and lose A3 plus A6, A5, sorry, A5 plus in the bottom of the file A2R plus A4R plus A6R, and then just press OK, and then at the bottom of the file we can see this new variable optimism here. But if we want to see the values, the numerical values of this variable, here in the left bottom part of the screen, it's a tab data view. Now we are in the tab variable view. We have to switch to the data view, and then you have to scroll and here we have this new variable optimism, and here we have, so for example, the first person in our data file has 19 scores of optimism. The second also has 19 scores, 23 scores, 24, and so on and so on. So in the SPSS, the calculation of raw score is the same, exactly the same. But after that, there is another one feature of Likert scale. We already mentioned validity, reliability, internal consistency, but there is another one, and this is normal distribution of raw scores. And what does that means? Normal distribution or Gauss distribution. I will use again whiteboard, but I will start new whiteboard. So normal distribution means that in one population, here we have mean, average mean. In one population, individuals which are close to the mean, which are equal to the mean, or very close to the mean, are many. If there are individuals which are very far from the mean, very far on the right or very far on the left, these individuals are exceptions. And when we are outside this zone, close to the mean, the number of individuals decrease rapidly. Here we have sharp decrease of number of individuals. And after that, we tend to close to the zero. Number of individuals is close to the zero. This is the idea, the concept of normal distribution. But why is normal distribution so important in psychology? Because if we choose here a border on mean -1 standard deviation, and here mean plus standard deviation, we know that in this interval there are almost 68% of all cases of all individuals. 68% of all individuals are between mean -1 standard deviation and mean +1 standard deviation. Since this distribution is симетрично на английски, пак ли си е симетрично? Че не мога да си сета друга дума.
Да, symmetric.
Symmetric, yes. Since this distribution is symmetric, the other 32% are divided in the left and in the right. So here we have almost 16% in the left and almost 16% in the right. And this is important because this is the usual way to define norm in psychology. Usually in psychology, individuals in the norm are between mean minus 1 standard deviation and mean plus 1 standard deviation. Accordingly, individuals below mean minus 1 standard deviation are below the norm, and individuals above mean plus 1 standard deviation are above the norm. But we must check whether our distribution is normal or not. And there are different ways to check normality of distribution. In topic lecture number 9, I will show you the most precise way to check normality of distribution. But now we will make only chart with an empirical distribution and with a normal distribution, and we will compare them. So I will use graphs. After that, I will choose a histogram, and after that, I will move a scale optimism in the bottom of the file, in the bottom of the data set, optimism. I will move optimism to the right, and we will check here display normal curve, and then press OK. And then let's see the chart here. So these yellow bars represent empirical distribution, and this black line represent the normal distribution. And here we can see that empirical distribution and normal distribution are not the same, are not exactly the same, are similar, and we could conclude that our distribution is close to normal distribution. And then we can calculate the borders of the norm as mean plus 1 standard deviation and mean minus 1 standard deviation. So here we have mean 22.1 minus 1 standard deviation 4.4. 4.4, and the difference is 7.1. 17.7. This is the lower bound of the norm, and after that 22.1 plus 4.4, and the result is 26.5. So if one particular person have a raw score between 18 and 26, we can say that this person is in the norm. If one particular person has a raw score below 17, we can say that this person is below the norm. And if one particular person has a raw score above 27, we can say that this person is above the norm. So let's switch again the presentation. Normal distribution and histogram, almost the same as in PSPP. Again, move scale optimism and check display normal curve. Again, compare empirical distribution with normal distribution. And we are ready.
Can
We
I
are
ask
ready
a
with
question regarding the distributions?
Yes.
In PSPP, do we also have to check for skewness and kurtosis of normal distributions?
Yes, we can check, but this will be in topic number 7.
Okay.
We will check. We will check about here. You could see skewness, kurtosis. I think we will check today. Okay.
Excuse me, I also have one question.
Yes.
How do we put the content of the, let's say, the survey or the questionnaire in the system?
Yes. As I already said, I will skip, and I already skipped the first 3 topics. How to enter data and how to check data for errors and how to prepare data for analysis is data entry is topic number 2, data processing topic number 3. Okay, I can show you briefly how to enter data, but after the break, because now is 11:30, and we have to make a break. After that, I will show, but very briefly, because we have no time for these technical issues. But you can find many teaching materials and teaching videos in YouTube about how to make empty data file, how to enter data, and how to check data for errors.
Okay, thank you.
Okay, and to finish, we are ready. We are ready because when we make real research, we will check validity, we will check reliability, we will check internal consistency, we will compute raw scores of the scale, and we will check normality of distribution. And that means that we are ready with our scale. But very serious question is the question about interpretation. What does that mean 19? What does that mean 23? What does that mean 10? Sorry, 10. We have to make interpretation of these values. We have to give a sense of these values. And how we do this, we will see after the break. So this is the slide about interpretation, and we will start with it. after the break. Now it is 11:40. 50 minutes break means that we will start in 11:55. And now I will stop the record. And